Alright, this is section 8.2. The goal of this lesson, basically what we're going to do today, is we're going to graph those complex numbers that we watched in 8.1 and worked with in 8.1. And then we're also going to write them in trigonometric form, and this is just going to be a heck of a lot easier way to use them and actually apply them in a problem. Alright, so the main things you really need to get out of this page right here is this is your trigonometric form. Alright, instead of having your real part, let's say 3 plus 2i or something like that. The 3 would be the real part, and then the 2i is your imaginary part. We're going to write it in terms of r. Okay, r is just going to be the distance from your origin to the point when we actually graph it, and that'll make more sense in a little bit. And then we're going to, instead of having like the real part's going to be like your x value. We're going to say it's in terms of cosine. Okay, and then the imaginary part is the y value part, or the second part, and we're going to attach sine to that. Okay, so there's going to be different things that are going to be involved. The true mathematical terms, the modulus is going to be your distance. It's the absolute value. Modulus, magnitude, whatever you want to say it. All those are quick, crazy mathematical terms for just distance. Okay, and then theta is the argument. Okay, theta is going to be involved with the from home base, where are we going in the complex plane? Alright, and this is going to make a little bit more sense now as we graph this. So just to graph things, alright, all you really need to know is basically the complex plane is just no different than any coordinate point. This is going to become your x value, this is going to become your y value. Okay, so what you're going to do basically is we're going to go 1, 2, 3 units right and 1, 2, 3, 4 units up. Alright, and that's where we end up. And you end up making essentially a right angle, if I actually could graph this correctly. Okay, so this would be 3, this would be 4. Your argument, your theta, is from home base to where we end up, and that's basically graphing a complex number at its finest. It's not very hard. It's really no different than anything before. We just need to make sure that we know that the x value is the real part, the y value is the imaginary part. All right. So let's go back and do this same thing, and I want to now find your modulus and argument. So going back to the mathematical terms of the one we just got done doing. So if I end up actually drawing this out again, what we just did on the previous slide, you guys wouldn't have to do that if it's on the same page. Alright, 3, 4. Well, you need to try to figure out now, first things first is the modulus. Okay, remember that's just a fancy word for the distance. This is your r, your radius, your modulus. What will that end up equaling? A lot of you can look at that and know that it's going to be 5 because it's, hey, right triangle, 3, 4, 5 triangle. If you don't know that, if you go back to the previous or 2 slides ago, this is just your distance formula. Okay, so all you got to do is just take the square root of, so r equals 3 squared plus 4 squared. Okay, square root of what? 9 plus 16 square root of 25 is 5. Alright, so that's how you can find it, whether it's nice numbers that I have or more difficult numbers. It's the same idea. So we know that our modulus is 5. Now, to find your argument, and what we're going to do is we're going to end up argument's an angle. Okay, so what do you know? Well, you can use any sort of trig function that you want. Okay, to find theta, you could use cosine, you could use sine, you can use tangent. It doesn't matter which one, because technically we have all 3 sides now. This is my argument. That's my theta. How do you go about finding that? I like using the stuff that's given, just in case we do something wrong with the 5. So if I have opposite and adjacent, I'm going to go tangent theta equals 4 over 3. So what does that angle become? If you take tangent inverse of that relationship or that ratio in degree mode, you'll get 53.1 degrees. Okay, and now if I want to write the complex number in trigonometric form, alright, what you gotta do now is also back up. What's trigonometric form? It's going to be z equals, oh, wrong way. So z equals your r, and then it's cosine theta plus I sine theta. You should have all those pieces of information. R is your modulus. What is R? We found it as 5. Alright? What theta are we at? The modulus is just telling you where to graph it. we can use it in terms of distance and its angle, no different than we can with side by side. It's just using different components of the triangle. All right? My angle that I found is 53.1 degrees. So this becomes my trigonometric form. All right? Trigonometric form involves your modulus, your distance, and then the angle from home base that it's actually drawn at, and that's no different than me telling you 3 to the right and 4 up. Okay? I'm saying the distance is 5, angle is 53.1 degrees. You will get the same triangle, the same idea. All right? So what if I want to work backwards? If I give you trigonometric form, can you give me standard form? So standard form refers to I want the x and the y value basically, and I need to try figure it out beyond that. Well, what do you know about this? I know that this is my r, my modulus. I know this is my argument. So I know that 120 degrees is the angle that I'm going. So I know I'm going this way. This is 120 degrees. But I don't necessarily want 120. I want the angle inside. I want my reference angle. I want this 60 degree angle. Okay? And if I know that that's 60, I have a special triangle that I can use. Alright? So if I know that, and really I didn't really need to do much beyond that. Okay? My R is 6 though. Okay? So that's where some of us are going to get thrown off. Well, that's fine. This is technically 2, but we're going to use that as 6. But to solve this problem, I don't need to have it line up accurately. I wouldn't have to multiply this by 3 to actually do this problem. I could if I wanted to. Okay, and I'll get to that in a second. But as long as you know how to find this number and this number, you can answer the problem. Okay, because it's just going to be 6 times what is cosine of 120. Okay, cosine of 120 is negative 1/2. Alright, plus I times sine of 120, opposite over Jason, is root 3 over 2. Alright, and if I want to write this in standard form, I just got to multiply that 6 through. And if I multiply that 6 through, it would be negative 3 plus 6 over 2 is 3. That would be I3 root 3. Okay? So there's a variety of things that can happen in that. Now, technically, this is our standard form. Okay? Now, could you have solved it with this triangle, what I was kind of talking about before? If you know that your radius is 6, how do I make that 2 become a 6? Okay, I have to multiply it by 3. So this whole triangle's got to get 3 times as big. So if I have to make this x value 3 times as big, that's negative 3. Multiply this y value 3 times as big, that's 3 root 3. Notice what happens. Your real solution is your x value. Okay? The imaginary one is the y value according to your r value is 6. Notice these numbers happen to show up as well. So there's 2 different ways that you could go about doing this. Now I'm going to tell you 99 times out of 100 the way I did it the first time is the best way. Just go find your cosine 120 off your triangle, the sine 120 off your triangle, and then you just multiply it through, because sometimes the numbers aren't going to be as easy to go from 2 to 6. It could be 7, and then you're just setting yourself up for trickiness. Okay? So if I just say I want you to sketch my trigonometric form, alright? This isn't that bad. All you got to do is know where 210 degrees goes. So we just kind of done this. We've done this before. So 210 degrees, I know it's here. Alright, there's a right angle. I know that's 30 degrees. And then all I know is I got to go 1, 2, 3, 4 units. That's not equally spaced, but you guys get the idea. I know that has to be 4 because this is my radius. Now, if I want to make it accurate in a coordinate plane, technically I need to know those sides. Okay? So if I know that this is 30 degrees, now I'm going to basically do this separately here. If I know that 30 degrees, 1, 3, 2, they're both negative. Okay? What would cosine of that 210 end up being? Cosine would be negative root 3 over 2. So I'm going to end up having 4 negative root 3 over 2 plus I times, what's sine going to be? Opposite over hypotenuse would be negative 1/2. And if I multiply that 4 through, I would end up with negative 2 root 3 plus what? Negative 2i would technically be my standard form. So technically in a coordinate plane, if I'm actually going to do this in a coordinate plane, I'd have to go negative direction for the x 2 times the square root of 3. Alright, 2 times the square root of 3. Going to put you somewhere just past 3, I suppose. And then negative 2 down is going to put me there. So that's the idea. This way and then down 2. Here's where I actually would end up in a coordinate plane, because this should be 4 units long. Okay? And this would be negative 2 root 3. And this would be negative 2. So that's kind of the relationship that you're dealing with if you work for it that way. Alright? So that's how you would go about sketching it. Now notice that is the exact same picture as you just going this direction and going 4 units that way. It gets you the same thing. It's whether you want to use the angle and the hypotenuse, or your modulus, whatever you want to call it, or do you want to use the x value and the y value, and that's the choice that you're going to have to make. Alright? So let's just do a couple more, 2 more, just quickly. Write it in trig polar form, trigonometric form. So you need what 2 things? I need to find r, and I need to find theta. Alright? So if I know that I am going, and usually what I'll end up doing is just drawing this because it's so much easier. 1 to the right, and then what am I going to do? Root 3 down. So if I know I'm going down, I'm going 1 to the right, negative root 3 down. Well, 1, 2, square root of 3, this is a 2. That means this is a 60-degree angle. And if I know that that's a 60-degree angle, what is theta going to be? Now, here's the thing. When you guys do this in trigonometric form, alright, obviously your radius is 2. I just kind of gave that away. But this theta, it's not necessarily just 60 degrees. It's from home base now. Because you need to know what area or what angle you're actually going to draw, what quadrant we're in, type of a deal. So from home base, 360 minus 60 is 300. So that's the angle you're going to put into your form. So now that I know my radius is 2 via the triangle, or, remember, you always can do the distance formula if you don't recognize that it's a perfect right triangle or a special triangle that we've used before. Square root of 4 is 2. Okay, so that's another way you can get the 2. Now, z equals your radius, 2. And then in parentheses, remember, it's the x-coordinate or cosine of the angle from home base plus I times sine of that same angle. So there's my trigonometric form. So z equals 2. Remember, this is just your radius or modulus. And this is your argument, your angle from home base to the direction that we end up going. Alright? And then this is actually the same exact one going backwards. I'm not sure why I did that. I think that was a mere coincidence. But if you're going to work backwards, okay, or just graph this thing, remember that you need to go to that angle. Alright? We know I'm going that far. You're going to make a right triangle. It's just the way it's going to be. And then you know this distance is 2. And you know that this is 60 degrees. And really, that is graphing it in a complex plane at its finest right there. And if you happen to know the angle and it works for a special triangle, you're going to know that this is negative root 3. You're going to know that that's 1. Okay? So then if I say, hey, write it in standard form. Standard form, you just need to know the x value is your real solution. Okay? And then your y value is your imaginary. And that's as simple as it has to be. So those are the main things that we're going to work through in class. Here's your assignment, and hopefully that was simple enough. So you guys have a wonderful day.